Good afternoon, everybody. It is day 7 of the Advent of Code, and I am back for today's challenge. After working with our device yesterday, we see that we are going to need an update. We notice here that as we try to run our update, we're seeing an error, no space left on device. Now they're asking us today, perhaps we can delete some files to make space for the devices. We browse around this file system to assess the situation, and we save the resulting terminal output, which will be our puzzle input. The file system consists of a tree of files and directories which can contain other directories or files. The outermost directory is called /, so you can navigate around the file system, moving into or out of directories and listing the contents of the directory that we're currently in. Within the terminal output, lines that begin with $signs are commands that we executed. Now these are actually Linux commands that I recognize right here. cd meaning to change directory, ls or list prints out all the directories and files in the current directory we're in. Now we'll be getting an output such as 123 ABC, which means that the current directory contains a file named ABC with a size 123, or we'll be getting something such as dir, short for directory XYZ, which means that the directory we're currently in contains another directory named XYZ. Now since the disk is full, our first step should probably be to find directories that are good candidates for deletion. The total size of a directory is the sum of the sizes of the files it contains. To begin, we need to find all of the directories with a total size of at most 100,000. Then we can calculate the sum of their total sizes. Looking at our input over here, today is going to be a rather interesting to work with, especially the parsing here. Based on the way this is set up, we're probably going to have to create some tree-like structure since we're going to have so many directories within other directories. Then we're going to have to be going through them and figuring out what their total sizes are, and then having to be comparing those and finding out what the sum of the ones with a size less than or equal to 100,000 is. Alright, here we are over in VS Code with our day7.py file and our input copy-pasted into input7.txt, so let's get on to it. For starters, we'll go ahead and define a parser here, open up our input, and we'll go ahead and read in our lines. To start, we'll go ahead and clean them up a little bit and replace the $signs, split it all up, and get it from our read lines. Now for our directories and files names, we can remove both the dir and the file name because we won't be needing any of those for the comparisons we're doing. So for example, if line 0 is equal to dir, then we can go ahead and pop that. And likewise, if line 0 dot is numeric, then we can pop the value right after it because it will be the name of the file and we won't need that. Alright, now we'll go ahead and start building our final result. Now for the result, we want to have the command used and then the output that comes with the command. Now to separate between the two, we'll have a commands list up here where we'll keep track of what our possible commands are. We will loop through lines one more time, and then if the first value in each line is in commands, we will append it to our result list. However, if our value is not in the commands, then we want to append it to this second list immediately after the last commands, because if it is not in our commands list, it will be output from it. Now we can go ahead and return our result. And now with our parser built, we can start looking at creating a directory class which we will be using to store all of our directories. And this initialize function will take in a name, a parent, its children, and file size. Now the file's size right here is not going to be the total size that we have down here, but rather only the size of the files that it contains, not its children directories. Likewise, children is only referring to directories, not files. So next up, we need to be getting our parsed data into these directory structures. We're going to create a get directory that is essentially going to return a top level directory with all of its children being the smaller directories under it so that we can have a single variable to hold all of the directories that we create. From here, we will loop through our commands, divide each command line up into command and out. If our current command is equal to cd/, then we know that we need to change our current directory to the top directory. Likewise, if our current command is cd ... then we need to change our current directory to the parent of the current directory. If it is not though, however, change directory is the command we are working with, but that's not the second value. Then we're going to be needing to get that second value from it and then be using it to find the child directory that we're looking for. which for that we're going to be using a list comprehension to look through the children directory, and if that name is equal to the second value in splitting the command, then it will be in the list. Then that should only contain one value, so we'll simply take the first one right here. Lastly, if our command is equal to list, we need to do two things. One, we need to set our children equal to each directory in there, and two, we need to set our file size to the sum of all of the numeric values in the output. For our children here, we will simply use a list comprehension like this, and we'll simply make a new directory for I in the output if I is alpha, meaning it was a name of a directory. Then for the file size, we can simply set that to the sum of a list comprehension where we take in each value in the output, assuming it is numeric, and we convert it to an integer. Alrighty then, that should be our top directory completely created, so we can simply return our top directory, and we can use this to get any of the values we need from our directories lists. Now that we have created our entire directory structure, we need to go through our entire system and make sure that we set the total size of everything correctly, because remember, we've only calculated the file sizes so far, and we need to find the total sizes, meaning their file sizes plus their children's file sizes. And I think for that, we'll just be using some simple recursion. So we'll take in our top level directory here, and we'll be setting our top level directory's total size equal to its own file sizes plus the sum of a list comprehension where we use recursion to go through each of its children. Down here, we can simply return our directory's total size, which will be equal to this value right here, and now that should be done. So now to string all of these together, let's define a setup function right here, which will create everything for us. We'll have a parsed variable equal to calling our parser, a directory variable equal to calling our getDirectory function on parsed. We will call set sizes, and we will return that directory. Alright, with all of that finally out of the way, we can actually begin writing our process for the day. Now our process will take in two arguments. One, the directory that it's going to be working on, and the maximum value. Because remember, we are looking for directories that's total size is 100,000 at most. We will be returning the directory's total size if the directory's total size is less than or equal to maximum, else 0, plus the sum of a list comprehension using our recursion. And there we go, we'll be calling process again with child and maximum for child and directory.children, so we'll be doing the same thing for each of the children and summing them up. Let's go ahead and create a top level directory to work with, calling our setup function, a maximum value of 100,000, and we will print process with these two values. And there we have it, 1611 44.3. Let's head back to Advent of Code and check that out. We are back over here in the Advent of Code, so let us paste in that input right here and see what we get. That is the right answer. We are 1 gold star closer to collecting enough starfruit, and we can continue to part 2. We are ready to choose a directory to delete. The total disk space available to the file system is 70 million, and to run the update, we need unused space of at least 30 million. We need to find a directory we can delete that will free up enough space to run the update. To achieve this, we need to look at what our options are, find the smallest directory that, if deleted, would free up enough space on the file system to run the update. Back over here, we can go ahead and start defining our process 2. We just need to do the same thing again, except for instead of looking for that maximum value of 100,000, for each directory, if its total value subtracted from the current used value plus the needed value is still less than the system's total memory. So for this function, we'll be taking in 4 arguments. We'll be taking in our directory to work with, the size needed, the system size, and the used size. Once again, we'll be using a list comprehension with recursion, but we'll be taking the minimum value of it since we'll be looking for the lowest level value directory to delete. And to start, we'll have the directory's total size if the used size minus the directory total size plus the size needed is less than or equal to the system size, else we put the system size. And that will just be kind of a extra large value that we know will not be the smallest one picked, since we'll be needing to decide if we want this or not. For our second value, we'll be using a list comprehension that we unpack. Here we'll be seeing our recursion once again, where we call process2 inside this list comprehension, the only difference being the child for child in directory.children. And by taking the minimum of that, we should get the smallest directory that we need. So let's create our two extra variables, which will be our total, which is the 70 million bytes that it has as a total size, and our needed 30 million. Then we'll simply call process2 with top needed total and the total size of our top level directory, because that is the total size of all of the files that are currently being used and will be our used size. Let's go ahead and give this a shot right here. And we have 208,608,8. So let's head over to the Advent of Code and give that one a shot. All right, we are back over in the Advent of Code once more, and let us paste this answer in here, and look, we have the right answer once again, and we have completed day 7. All right, that'll about wrap it up for me today. Thank you guys so much for watching. If y'all enjoyed, please consider leaving a like or a comment, as that would be absolutely excellent. I'll have the code once more on my GitHub and that link down in the description. Thank you all so much for watching, and until tomorrow, goodbye.